And we're back at it. Finally got somewhere on this brake design. I got some 3D printed stuff sorted out. I've got my mountain bike brake with 140 millimeter world's lightest solid rotor installed, sitting next to my 6-inch wide and 11.5-inch tall go-kart tire, mounted onto a Hummel ultracruiser strut. Yes, there's too many holes in this. I will have that sorted out here soon. But the mounting fit, the mounting has clearance all the way around, the mounting is adjustable. It actually has all the clearance it needs internally, and I've got space for the banjo bolt fitting. I'm debating running the brake line inside of the strut, but I don't really want to drill any holes, and I don't know if I can fit it up with the clearance of someone else's welding on some of this. A lot of this is going to get cleaned up and redone before it is finalized, but the 3D printed brake adapter, obviously I don't have all the bolts in there, but that's all now metric instead of SAE, and we have metric bolts. We have M6. They're steel bolts right now. Those will all be titanium when it's done. The spacer itself, I'm actually burnt up the motor on my little mini lathe the other day starting on this project, so making that little white plastic spacer out of aluminum is the next step for me. There's the other one. That rotor, believe it or not, is only 64 grams. So it's a stainless steel rotor. It's the lightest single piece rotor I could find, and it happens to be the lightest single piece on the planet, minus going smaller, which 140 is roughly the same size as the rim, which should give me plenty of leverage. It's designed for a 24-inch mountain bike wheel, so that should be plenty of leverage over that wheel. I should be able to lock them up without issue. Of course, that'll flip me over, but I want more braking. Too much braking is okay, not enough is bad. So my titanium axle shafts, I got to clean up the threads just a little bit. No one told me that threading titanium is a pain in the butt, so I'll clean those up a little bit. That's pretty cool that I got that process done. I have magnesium rims. These are tubeless and magnesium. They're balanced with bead locks, so if I happen to lose air pressure, I shouldn't debead during landing. And then the wheel hub is magnesium. The studs are titanium. The lug nuts are aluminum. And the axle nuts are in the mail. Those are titanium. Those happen to be blue. Those should be fairly pretty. But yeah, we're trying as much as is possible to keep this as light as is possible. And the whole assembly might be 4.5, 5 pounds. It's incredibly light. So I'm keeping all the weight down as much as possible. I do need to go through all this and redo all this. There's some light surface corrosion on a couple pieces. There's some poor cuts. So we'll trim it all up, get it all nice and clean and true. Do up all the rivets fresh with all fresh anti-rust measures and whatnot done. At least as much as I know how to do with aluminum sheet metal stuff. So the next tricky part is doing brake lines. This is 5mm OD and 2mm ID. So I've got some material coming. I've got 3 meters, 2 separate colors, one for each side. And then, of course, the world of fittings. This actually negates an awful lot of weight savings on the calipers. I really hate this idea, so I might try to rebuild this out of aluminum or find a titanium one. I'll call up NASA and get a titanium one. But a 5mm compression fitting with an oil needle, I think is what they call them. The internal sleeve for a compression fitting. These are extremely difficult to find in this spec, in a 5mm OD spec. So I might just bite the bullet and deal with the lump of brass in the bottom of the plane, but it's incredibly heavy. This weighs a lot for what little it is. I know I only need one of them, but that's an ounce and a half. That should be a half an ounce, so every ounce counts. Every ounce counts in this case. But this is my, back to that spacer. This is a 3D printed spacer. So there will be either a grub screw or a through bolt. I might put a shear pin through bolt through these around the back of the bearing. So yeah, it's an 11 millimeter deep bearing, and that shear bolt would be in at least 11 millimeters past the back side of the bearing. And of course offset, so it goes through next to the axle. I'm not sure how deep into that I'll get, but I might just put grub screws in it with flats, machine flats, and magnesium. We'll see. There shouldn't be all that much torque here. Just based on the size of the wheel, the contact patch, and the weight, shouldn't be that much, and I won't be able to use the brakes all that much anyways, being a tail dragger. So we'll see how far it goes, but thanks for coming along. We will catch you guys next time.